Namaste and welcome to Code Divinity. I am your coding friend Om, and today we are going to look at an interesting easy level problem on LeetCode. That is problem number 66 plus 1. In this problem, we will be provided an integer but in the form of an array. For example, our integer is 925, so it will be represented as individual digits arranged in an array. The indexing will be done from the least significant number to the most significant number. And we have to do a very simple task here. We have to just add 1 to this. Hence, our final array becomes 5 plus 1 will become 6. 2 remains as it is because there is no carry, and 9 is also as it is. So this array becomes our answer. This problem seems a little simple, but there is a twist to this problem. Let's check it out. Let's take an example 999. This will be given as, now we will add 1 to this input. 9 plus 1 will become 10, so we will put 0. Then our carry is 1, so 9 plus 1 will become 10 again. Then again carry is 1, so 9 plus 1 will become 10. Now there is one additional carry. So where can we put this carry? Because our array is completely filled. So this is our edge case. And in such cases, we will extend our array and put this carry here in order to obtain our answer. So while formulating our algorithm, we have to be mindful that we cover this edge case. So we have checked the problem statement. We have checked few examples, including the edge cases. Now let's start framing our algorithm. First, we will start a for loop from size of input till the first element. So this is a backward iterating for loop. In this for loop, we will check if the current digit is less than 9. We have just started our for loop and we are checking from the rear of our input array. Thus, if the lastmost digit is less than 9, in that case, we will just add 1 to that digit and return the input back. This portion of our algorithm covers the non-edge cases, but in case the lastmost element is 9, so we will add 1 to it and all the elements in our array will become 0. So we will set the ith element to 0. As soon as the edge case is encountered, entire code will fall into the else block and the loop will continue to set all the digits to 0. And finally, when the loop will terminate, we will set first digit of input as 1. So this is the carry 1 which will be added at the beginning of our array. And in order to compensate for that additional digit, we will push a 0 behind and then we will return our input. Let us visualize an example over this algorithm so it will be much more clear. Let's take an example 1, 2, 1. So we will start iterating from behind. I will be pointing at this element. So 1 is less than 9. So we will add 1 to it and then return the array as it is. So it will become 122 and hence we have found our answer. Now let's take an edge case. I pointer will be set to the index 2. The index 2 is 9. In that case, we will set the ith position as 0. Then I will be pointing at the first index. So we will make it 0 as well. Then I will be pointing at the 0th element. So we will make it 0 as well. Now the loop will terminate. And for the edge case, we define that we will set the 0th element as 1. And in order to compensate for the additional digit, we will push a 0 behind. Thus, we found our answer. And our algorithm is working theoretically. Let's check it out by coding it on the platform. Visit this problem from the link given in the description below. And here they have provided us the problem description. We will be given a large integer in the form of an array and each digit will be positioned at the index I of that array. There will be no leading zeros. So in my previous video, removing the trailing zeros, I have also explained what are the leading zeros. They are the zeros which occur at the start of an integer. So our given input will not contain any leading zeros, and our task for this problem is we have to increment the integer by 1 and we have to return back the result. Let's check the examples given here. In the first example, our integer is 123. So after adding 1 to 123, it will become 124. So it is quite simple. Then 4321. After adding 1 to it, it will become 4322. So it is self-explanatory. And similarly, in this example 3, they have defined an edge case. That is, when the lastmost digit of the array is 9. In that case, after adding 1 to it, we will need one more extra digit space in our array. As you can see here, initially our input array size was 1 and the output array size is 2 because there is one additional digit needed for the answer. Now let's check the constraints here. So our input will contain one digit at least, and it can contain 100 digits at maximum. Digits will range from 0 to 9 only, and there will be no leading zeros in our. So this is an interesting question. Let's start coding it. First we will declare an integer n which will store size of our given input v. We will start a for loop from int I equals to n minus 1. That is the last digit of our given input. It will go up to 0, which is the first element of our given array, and then we will decrement our I pointer. This is a backward iterating for loop, so please be mindful to decrement the I pointer. Here we will check if the ith position is less than 9. If it is less than 9, then it is not a problem because we will just increment that digit and return our v as it is. Here we have covered the non-edge cases, but in case the last digit is 9, so we will have to set the digit as 0, and this will continue until all the elements in our array become 0. Now when the loop will terminate, we will set the first element of our input as 1, and we will push a 0 behind this array. So this will add one extra digit to our array and our algorithm is completed here. So we will return the v finally. Let's run this to check if it is working. So yes, it is working on all the example cases. Now let's submit it to check on all the test cases. So yes, we have successfully completed this problem. I hope you like this easy solution for this easy problem. Do like the video and subscribe to the channel if you like my way of explaining things, and I will meet you with another easy level problem very soon because we have worked on more medium level problems recently. So we will try to solve some easy level problems here on. Thank you so much for watching this video. I will meet you in the next video very soon.